This is one of the KTA Lunch and Learn series segments, Understanding SSPC Abrasive Blast Cleaning Standards and SSPC-VIS 1. My name is Ken Trimber. I'm your presenter. I have over 45 years of inspection and testing experience in the coatings industry. I'm NACE certified. I've got an SSPC Protective Coating Specialist certification, a competent person. I'm also the president of KTA, and I oversee the KTA's technical services and deliverables. As it relates to this particular segment, I'm the chairman of the SSPC Surface Preparation Committee. I've been that since the late 1970s. And I'm also the chairman of the SSPC Visual Standards Committee. The learning objectives are to understand the SSPC written blast cleaning standards and understand the use of SSPC-VIS 1, the reference guide of photographs that show you the different appearances of the various grades of blast cleaning. Here's a whole list of SSPC surface cleanliness standards. The ones in yellow are the ones I'll be talking about. They're the abrasive blast cleaning ones. Notice at the bottom you've got the water jetting standards. That used to be SSPC SP12. They've now been broken out into individual standards for various grades of cleaning. They will be the subject of a future Lunch and Learn. But for now, we're going to cover the ones that are in yellow. I'm also going to discuss SSPC-VIS 1, the guide and reference photographs showing you the appearance of different grades of blast cleaning. And as the last bullet indicates, the photographs are not to be used as a substitute for the written standards. The written words prevail. So the purpose of blast cleaning, to clean and roughen. In the bottom left, you see a microscopic view of a roughened surface from blast cleaning. See, it looks like sort of the waves or ripples in an ocean as compared to a calm sea, which would be a smooth surface with no abrasive profile on it. The grades of cleaning from the lowest to the highest are SP7 or NACE 4, brush off blast cleaning. Next grade, SP14, which is a little cleaner, industrial blast. A little cleaner yet, SP6, commercial blast. Then near white, and finally white metal. SSPC SP16 is another standard of cleanliness for non-ferrous metals. First, before going over the definitions and photographs, I'd like to go over a couple terms. Dull putty knife, you'll see that that's used frequently in the standards for assessing what may or may not remain after cleaning. There is a definition for it from the SSPC 2011 glossary. The dull putty knife is a commercially manufactured metal blade with a width 1.5 to 3 inches, length 3 to 5 inches, a thickness of 30 to 50 mils, and it's acceptable for use if the thickness is not less than 25 mils or 75% of the original thickness. The purpose of that is to make sure it's not overly sharpened during use. It can't be used if the edge is nicked or gouged or if materials on the surface that would allow it for making an intimate contact. And when you use it, you have to maintain a maximum 45 degree to the surface and keep it flat, not be digging into it with an edge. In terms of the putty knife, I've seen specifications require the contractor to provide the putty knife for use for this testing. That way there wouldn't be a complaint or issue that is too sharp for the assessment. Another definition that I want to talk about is stain or staining. You'll note in the standards that stains are allowed to remain. But what is a stain? According to the SSPC glossary, it's an area of a surface which, when compared to the adjacent areas, has an equal surface profile, which you see this whole sample on the left has an equivalent surface profile or roughness. But it's this color, which is usually darker, with a material that has no apparent volume. It can't be removed by blowing or brushing down or vacuuming, methods that are used to remove dust, but it could be removed by more thorough abrasive blast cleaning when blast cleaning is used, or more thorough power tool cleaning when power tool cleaning is used. And just as a comment, a suggested test for assessing whether something is a stain or not. Now, this isn't an SSPC test, but it's something we use. Use a utility knife, scrape the surface, press the blade into the residue. If the residue is dislodged from the surface, it's not a stain, it's a material. But if that residue isn't removed, it's a stain, almost like a marker. If you put a marker on the surface, it stains it. You can't actually remove that marker. Another item, you'll see 9 square inches is repeatedly used in the standards. And the history of that is, prior to developing joint standards, in other words, SSPC and NACE used to produce their own versions of the blast cleaning standards, but then they became joint standards. But before that, The percentages of allowable staining between SSPC and NACE were the same. Commercial allowed 33% staining. Near white was up to 5%. But the unit areas were different. SSPC said that staining applied to every square inch of the surface. NACE said the percentage applies to the entire surface, provided it was evenly dispersed. Some criticized the NACE standard, saying that could mean someone could prepare 3 walls and not a 4th wall, for example, and have it comply. Well, that really didn't make sense. But regardless, there was a concern with applying a percentage to the entire surface rather than incremental unit areas of the surface. The compromise at the time was to use 9 square inches because that was the size of the reference photographs that we'll be discussing here shortly from the visual guides. And at the same time, NACE had reference coupons that were blast clean steel sealed in plastic to keep it from rusting of the different grades of cleaning. Well, now those blasted panels don't exist anymore, but the 9 square inches has remained as the unit area for the various surface preparation standards. Let's talk about the definitions. This happens to be a gray paint you're seeing. So the gray is paint, not bare substrate. But SSPC SP7 or NACE 4 brush-off blast cleaning, basically you sweep across the entire surface to remove loose rust, loose paint, loose mill scale. Tightly adherent material can remain. There's no restrictions on the percentage of material on the surface or any differences between staining or material. The dull putty knife, which we've described, is used at the edge of the material to see if it's tight or not. And you view it without magnification. Now, magnification does not mean you cannot use a mirror. A mirror is not magnification. It is permitted. It means you can't use a microscope or a magnifying glass to look at the surface. A caution: when using brush-off blast cleaning on existing coating, you need to be careful that the coating is sound enough to withstand the rigors of brush-off blast cleaning. In other words, when you abrasive blast clean, the abrasive may come out of the nozzle 400 miles an hour, so it can really beat up the existing coating. There are times that a brush-off blast on an old coating has created problems by fracturing and weakening that coating, although you don't know it. You put another coat on top of it and it pulls that old coat apart in service. So brush-off blasting should be used only in the right circumstances. Make sure the surface is a suitable candidate before you specify brush-off blast cleaning. SSPC SP14 or NACE 8 is industrial blast cleaning. Industrial blast requires removal of all loose rust, loose mill scale, and loose paint. What's loose or tight is determined, again, using that dull putty knife. It allows, though, intact paint or rust or mill scale to be present on up to 10% of each 9 square inch surface area. Stains then can remain on the rest. It also allows more material to remain in difficult configurations, such as back-to-back angles. If, in fact, you would subject the entire area to the abrasive blast, and at the end of that time, the material remains more than 10% of the area, it's allowed, provided it's tight. And again, this surface is viewed without magnification. The next one, SSPC-SP6 or NACE 3 commercial blast. This requires a removal of all mill scale rust and paint. In this case, only stains are permitted. No material is permitted to remain on the surface at all. You can have this staining on up to 33% of each 9 square inch surface area, and it must be evenly dispersed. And again, the surface is viewed without magnification. Near white blast, SP10 or NACE 2, is basically the same definition as commercial, except that staining cannot exceed 5% of each 9 square inches of surface. The rest is the same. All rust, mill scale, and paint are removed. Only stains can remain. The final degree of abrasive blast cleaning for steel is SP5 or NACE 1, white metal blast. In this case, everything is removed. All material, all rust, all staining, and so forth. Now, this does not mean when you look at a surface you won't see any shadows, because you will see shadows. There are shadows by the angle of the blast cleaning, of the abrasive that is used. That is permitted. In order to determine if something is a shadow or actually material that should be removed in the profile, just look at a darkened area, change your viewing angle, walk along the scaffold, look at a different angle, or change the angle of the lighting. And if the dark area turns light, and the previously lighter areas turn dark, you know that's an indication that this is just shadowing. It's not a material to be removed. But if you change your viewing angle, you change the lighting angle, and the dark areas are still dark, that's an indication that it is a material present that should be removed. So as a quick recap before we move to the visual standards, SP7 brush-off blast cleaning removes all loose material, anything tight can remain. SP14 industrial blast cleaning removes the loose material everywhere, but tight material can remain on up to 10% of each unit area. Stains permitted on the rest of the surface. And in limited access areas, the 10% restriction doesn't apply, provided those areas have been subjected to the abrasive blast and the coating's intact. SP6 commercial blast removes everything except staining. Staining is allowed on up to 33% of each unit area. Near white blast, SP10 again removes everything except staining, but in this case, less staining is permitted, only up to 5% of each unit area. And SP5 white metal blast removes all rust, paint mill scale, and all staining. SP16, it's not a joint standard, so it doesn't have an ACE number, but SP16, brush-off blast cleaning of coated and uncoated galvanized steel, stainless steel, and non-ferrous metals, again, is not for carbon steel. It requires blasting the entire surface to remove all foreign matter. Paint can remain if it's tightly adherent, and the dull putty knife is again used. But a dense and uniform surface profile is required. Now what you're looking at here is a piece of stainless steel. Left half is in the original condition. The right is after SP16 brush-off blast cleaning. You can see the roughened texture from the profile, and yet there are some very fine, smooth areas in between. So in this case, this would comply with an SP16 by roughening that surface uniformly and densely. Now for the visual guides. You see there are 4 SSPC visual guides here for surface cleanliness. The one on the left is a dry abrasive blast cleaning. That's the one we'll be discussing. VIS 3 is hand and power tool cleaning. VIS 4 is water jetting, and VIS 5 is wet abrasive blast cleaning. Again, we'll just be discussing SSPC-VIS 1. SSPC-VIS 1 was published in 1989 and updated in 2002. It has reference photographs that are divided into 4 sections. The original standard was only previously unpainted steel, and the new additions in 2002 added the appearance of the grades of cleaning over painted steel. The first 2 bullets you see here are from the 1989 standard. The appearance of SP7, 6, 10, and 5 is shown on steel that was never painted, different initial conditions of steel. And it was also a series of photographs taken showing an SP5 produced with different metallic and non-metallic abrasives, showing that while the cleanliness was the same, the appearance is dramatically different depending on the abrasive used. Then in 2002, photographs were added showing the appearance of the same grades of cleaning on previously painted steel, but in addition, SP14 or industrial blast was added because that standard was published between the time the original VIS 1 was prepared and the new one. It also included another series of photographs showing the effect of the surface profile depth or angle of view and lighting on the appearance of SP5. Prior to 1989, SSPC used the Swedish standards, which are now an ISO standard, ISO 8501. Those still exist. There are some differences between ISO, though, and SSPC. So if SSPC-VIS 1 is specified, those are the standards you need to use, the visual reference photos. Now, the initial conditions. In 1989, there were 4 initial conditions. A, intact mill scale. B, rust and mill scale. C, totally rusted. D, totally rusted and pitted. The standard then shows the grades of cleaning over those initial conditions. In 2002, previously painted was added, and you've got condition G1, aged coating with extensive pinpoint rusting, G2, aged coating with moderate pitting, and G3, aged coating with severe pitting, again showing the grades of cleaning over that with SP14 added to it. So here are the initial conditions. In 1989, the 4 on the left, rust grade A, intact mill scale, B, rusty mill scale, C, rusted, D, rusted and pitted. Then on the right in 2002, you see the 3 grades of previously painted steel that were added. So In order to use the standard, you turn to the section showing the initial condition, and it'll show you the different appearances of the grades of cleaning over that initial condition. There are no photographs available for SP16 brush-off blasting of the non-ferrous metals. So this is just for the steel blasting specifications. So here's an example of rust grade B. The initial condition on the top left, bottom left, that would be a brush-off blast. Top right, commercial, near white, and then finally white. So that's the progressively increased grades of cleaning of that initial condition B. If my initial condition is rusted and pitted steel, I turn to condition D. And the bottom left, we've got the brush-off blast. Then the right, the same sequence. Commercial, near white, and white. Here's an example of some of the new standards photos added for previously painted steel. The initial condition on the top left, there you've got the brush-off blast. The bottom left, SP14 industrial blast. Top right, commercial, then near white and white. And now here's badly rusted initial condition. On the top left, you've got SP7 brush-off blast. Beneath that SP14, you see most all the paint now is removed. The gray is substrate, although there are traces of actual paint remaining as well as staining. In the right-hand column, you've got commercial blast, then near white and white. Note this though, for condition A, you'll see there's just SP10 and SP5, or near white and white. There are no photos for brush off and commercial. The reason is, by the time you blast clean intact mill scale, to remove all the mill scale and only allow stains to remain, your cleanliness is going to be in SP10 or better. It's really difficult to remove the mill scale to a commercial blast grade of cleaning and allow up to 33% staining. By the time you take the mill scale off, the staining is almost non-existent. The point is then, if you have a surface with an intact mill scale, you really can't get a commercial blast. There is no picture for it. This shows another series of photos that represent a white metal blast with different abrasives being used. So when you step back and look at that, you see all the different colors and hues. This is not a color standard. That's the point of these slides. This is a cleanliness standard. So when you look at it, these are all white metal blast. The top left is the baseline that was used, frankly, with silica sand. Silica sand was used for all the standards because it didn't impart a color to the surface. You've got two other non-metallic abrasives on the bottom of that column, and then on the right, metallic abrasives, again showing the difference in the appearance, all being white metal blast. So it's important when you're making your inspections, you're looking for staining or discoloration, not discoloration caused by the abrasive itself. Those are all white metal. Another series of photos shows the effect of surface profile on the left. You've got a 1 mil profile on the top, 4 mil on the bottom. Makes the surface look different, even though it's the same degree of cleaning, white metal. And on the right, you'll see another with the profile, 1 mil profile on the top, 4 mil profile on the bottom, in this case over badly pitted steel. So the profile can have an effect on the appearance. Another is lighting. Here's the exact same photo, exact same sample with different lighting. In the first case, the lighting is nearly perpendicular to the surface. In the middle, it's a very low lighting angle, so you can see a lot of shadows, so it makes the surface appear differently. And then on the bottom, it's a diffused light, something that might occur on an overcast day. So that is the exact same sample showing you the difference in appearance just from lighting. The point being, the time of the day that you inspect the surface can affect the appearance. In order to really use the standards and the reference photos, it's best to do job site standards, because in this case you're really incorporating the effect of the steel, the abrasive, the existing condition, the profile, everything into that test area that you can't find in photographs alone, because photographs will never look like the surface. So in this case, prepare the job site standards, agree that this is in fact the degree of cleaning specified for the job, and use it to kind of hone in and adjust your eye to recognize the degree of cleaning required. It's a very effective way to eliminate disputes with regarding to the degree of surface preparation required and being achieved. One way to help you adjust your eye to make that, in addition to the visual photographs we just talked about, is to use this standard. Now, this standard is SSPC-VIS 2, which is a standard method of evaluating the degree of rusting on painted steel. It's really used to communicate the amount of rusting on a surface. That's its purpose. But the pictures in this are a great aid in determining percentages for surface cleanliness evaluations as well. The standard shows a series of photographs and black and white images representing different percentages of corrosion ranging from 0.03% to 50%. It shows them in different distributions as well. What you see here is general rusting, but also has spot rusting, larger spots showing the different percentages, and also has a series of photos for pinpoint rusting, showing the appearance of pinpoints of rust over those same percentages. What you see here is general rusting, 1% photo on the top left, 1% the black and white images. The middle one, 3%, and the bottom one is 10%. So the value of using it is this. You can use this to kind of adjust or calibrate your eye. As we've already mentioned, SP14 Industrial Blast allows material to remain on up to 10% of the surface. Well, if you look at the bottom image, that's 10%. That gives you a nice feel for how much material can actually remain on a surface and still be within 10%. And note that this is only one of the three depictions. There's also the pinpoint rusting and the spot rusting, different distributions of that same 10% in this book, in this standard. Here's an example of the pinpoint rusting. As we mentioned, SP10 allows up to 5% of the surface to have staining. SP6 allows up to 33% of the surface to have staining. So here you're looking at pinpoint rusting from 1% to 50%. So if you look at the first column, the bottom two, the equivalent staining for a near white would actually be between that middle block and the bottom block. The middle is 3%, the bottom is 10%. 5% would be between the two. The amount of staining allowed for a commercial blast would be the middle block on the right, 33%. This is very surprising to people. They really often require a degree of cleaning greater than what the standards truly require if you really try to estimate the percentage of staining permitted. That's why, again, these VIS 2 can be a nice aid in making judgments. So summary, we talked about SP7 removing loose material, no percentages. SP14 Industrial Blast removes all loose material again. Tight can remain on up to 10% with the exemptions in the tight configured areas. Commercial Blast removes everything except staining. Staining can remain on up to 33% of each unit area. Near white, everything's removed except staining. Staining allowed on up to 5%. White metal removes everything. SP16 uniformly roughens the surface. Intact paint can remain. And then SSPC-VIS 1, the guide and reference photos for steel surfaces. It supplements, it doesn't replace the written standards, but it's a very nice tool for depicting the appearance of the different grades of cleaning. And then SSPC-VIS 2, which we mentioned, as a nice standard to help maybe calibrate your eye in estimating percentages. That's the end of this Lunch and Learn. If you have any other questions regarding this subject, feel free to contact me directly or contact us at www.kta.com. And also look for other Lunch and Learns in this series.